In this video, we are trying to attempt that we can revise statistics of your 12 Edexcel course in 1 hour. And I've taken some questions from Dr. Foster's PowerPoints and some past exam questions, which are freely available on the internet. Okay, so let's start with this first question. I've divided into skills. Skill 1, 2, 3 is covered in this first question, and we will see what we can do with this in 1 hour. Let's have a look. Okay, the skill 1, 2, and 3. We have decided that we'll be calculating mean and standard deviation from a given group data, and we'll do two things in there. We calculate this just by using calculator, and we calculate this by without using this formulas or given values, so that we have understood both. And then we use the linear interpolation to estimate the median and the lower quartile, just to say that we can cover everything in there. Step 1, in using calculator to work out mean and standard deviation, you will need to know that how do we put in the data into the calculator. And for the intervals, you'll put the midpoints of that, and for the frequency, obviously you put the frequency. But you need to know if you know how to do the frequency on in the calculators. Okay, try that now, and I'll show that to you in a second. Quick one. So we do home, we go to stats, okay, and one variable, and frequency is already on. If it wasn't, you go into tools, it says frequency there, and then press on, and you'll get the data like this. Okay, frequency will be, well, we need frequency here. Then what do you need to do, people? Type in the midpoints of these, okay, and then frequency. Then advisable, because you need to do interpolation after that. It's good idea to make them into continuous, not discrete, and type in the midpoints and frequency. So once you put in the data, you press OK, and this one variable results. So execute, and you get the first one, which says X bar is the mean, 24 point something, and then sigma X is the standard deviation, 9.2936. Follow these steps and get these answers, mean and standard deviation, and obviously write them at least up to 3 or 4 significant figures. Do not round them too early. If we are insisted that we need to work this out using formulas, so mean is sigma ft over sigma f. What does that mean? We multiply the midpoints with the frequencies, and then add them all together. We get the total on the top, and then at the bottom we add all the frequencies, get the total at the bottom. Okay, divide and work out mean. I will let you do that. Standard deviation is the square root of variance, and variance we calculate using that mnemonic MSMSM. So what does that say? Mean of the squares. So mean of squares, that means we have to square the data, then add them all together, okay, and then square of the mean. And that is a minus in between. So people, luckily, you have this part, the total of squares given to you. You can see that here. That is 134,281.25 over 200. That's mean of squares. Take away square of the mean, and we put that in the calculator to get the answer. And the answer comes out like this. And this, obviously, we use the mean which we found in part A. Okay, that's how we find mean and standard deviation with calculator, without calculator. With calculator by typing in the data, and with calculator using the formulas. Okay, we go on to interpolation now. To use interpolation to work out median, quartile, or any other measure of centered tendency, what you need to do, what I would do first, people, I work out the position and the location of these two important points, guys. Position, median is half of the data. It's 200 divided by 2. Position is 100th position. For lower quartile, it will be 200 divided by 4. It will be 50th position. We need to look for where the location is. That means which interval they both lie in. To find the location, I look for work out cumulative frequency, and I'm looking for the 100th item, which is in the second interval. So location is 20.5 to 25.5. That means the answer should be somewhere in between that. And over here, the location would be, this is 50th, that is 10.5 to 20.5, because 50th will be here. That's the location. Then we use either the line method or we use that formula thing, or just basic calculation. We do both of them now for you. Okay. Look carefully. We decided median is in this interval, so it will be 20.5 plus. Then there's a fraction, and it's times by the width of the interval, which is 5. What comes in the fraction very carefully. 62 items finish in the first interval. We need 100, so that means we need 38th item. How do I get that? I do 100, take away 62, which is 38. Okay, but in this interval, there are total 88. So, or I do 150, take away 62. So remember that the position, take away the cumulative frequency before that on the top, and cumulative frequency and of the interval and cumulative frequency before that, take away at the bottom with just that 88 and times by 5. That should give you the median. But similarly for lower quartile, because it's the 50th item is in the first interval, so we're starting with 10.5 plus. We need to do what, people? We need to take, in this one we did, it's in this interval we did 100 take away 62. Before that, this is 50th take away, and what's the cumulative frequency before that is 0. There's no interval there, so 50. At the bottom, it will be frequency of that, which is 62 there. Okay, and times by the width of the interval. Width of the interval we're looking at, this is 10. Right, work out the calculation and see what the answer is. The quick one, the line method, which textbook does. I'm doing it for median. Median position is 100. So that's the median position is 100. It's between 20.5 to 25.5. And what do we put at the bottom? Are the two cumulative frequencies. So once before that interval and over here in that interval. So what do we do after that? We do two fractions. Okay. Then from center to left, that gives you m take away 20.5. Whatever you do to the top, do the same to the bottom. So the bottom is 100 take away 62. Then right to the left, this is 20.5 take away 20.5, 20.5, 25.5 take away 20.5, and over at the bottom 150 take away 62. Simplify, make m the subject to get the same answer. The next skill, which is skill number 4, is estimating mean and standard deviation from the coded data, and that is the question. So once we calculated mean, standard deviation, and quartile, then how can we use coded data to work out the mean and standard deviation of the other code? Okay, have a look now. I have been given some statistics about x, the total, and total of the squares. N is 8, so I will need to first work out my mean and standard deviation of x. Can you do that, please? We've just learned in the last slide. Okay, mean and standard deviation of x, please. That's a start. Well, I would like you to pause the video now and work out standard deviation yourself for x. Okay. So standard deviation using MSMSM. These are the calculations. Work the answer out. These are the two answers. Now we need to use these two answers to work out the mean and standard deviation of B. So my advice, what we should do, you can rearrange this formula to make B the subject. That gives me 2x is equal to B minus 21. So B equals 2x plus 21. Okay, and then comes the most important bit, people. You should know that mean gets affected both ways. So it is 2 times mean of x and plus 21. For standard deviation only gets affected by multiplication and dividing. It should just be 2 times standard deviation of x. Put that values in and find the answer, mean and standard deviation for B. And these are the two answers I check if you match with my answers. And then I will show you a question which you need to do practice and which you need to do yourself. Okay, try pause the video and work this answer out, and then you can check the answers which are given at the bottom page upside down. Wait to do it yourself, then check the answers there. Next, we move on to histograms. There's two types of questions. Number one is when you have to complete an incomplete table or histogram. Number two, when histogram is not given, but they give you length, width, and the height of one bar, and you have to find width and the height of the others. We do the first type of question first. Okay, so there's the question. Have a look, pause, and have a look and try and work it out yourself. Then we can see my solution. Right. In these type of questions, you're looking for one interval which has the frequency and as well as the bar given to you to use that to label our frequency density axis. And I can see from here, it is this one this time. I've got the frequency 45. We've got a bar as well. So guys, frequency 45 should be the area. So let's try to see what it is. This is 15. And 15 times 3 should give you 45. That means this should be 3 the height. So that clearly tells me one big square is going into 1, 2, 3. So 4, 5. Once we've labeled it, things get slightly easier from here now. Right, for the first interval then, 0 to 5, the width is 5, frequency is 5. So I need the height of that to be 1. So that is the bar for the first one. Okay, 20 to 9, 20 to 40, that is 20, and this is 90 is the frequency. So let's find the height. 90 divided by 20 is 4.5. So going up to 4.5, so this is 4, so somewhere in the middle of 4. This will be 4.5, and we can count this 4, 1, 2, 3, 4, 5. So this is 4.5. So that becomes the height of this bar to give the frequency 90. Okay, now we're doing the other way around. I need to work out this. That's 40 to 65. The height is 25 there. And the width, it goes up to 5.2, I guess. So 5.2 times 25 should be the answer for this one. And the next, right? So going by the same formula, we get 130 is the frequency for that interval, 60 is the frequency for that interval. So we have completed histogram and the table both. All right, moving on. So we've gone on to the second type of question in histogram when width and the height of the bar. Look, histogram is not given. So they just gave me the histogram was drawn to represent, they're giving me width and the height of one interval. I need to work out the width and the height of the second. Obviously, the first part A is midpoints. I'm sure you can do that. So fill up the midpoints and have a strategy about part B, pause it, then look at the solution. And width and the height of the interval should be, I don't know if I should be talking about it, but I will. And how do you find the midpoint, people? If you completely have blank mind, just add the two together, divide by 2. Okay, that's the interval square. This is an important question, the next part being. I've seen a lot of people making mistakes in this in my experience as examiner for many long years. Okay, so try and learn this very clearly, very carefully now. I will run this slowly because I've seen problems with this question. So guys, first step, I will note down the given and the required. They've given me height and width of 11 to 20. They want me to find height and width of 26 to 30. Step 1, I will find the class width of this interval. And remember, we need to make them continuous. This is 10.5 to 20.5. So that is 10. Okay, so class width here is 25.5 to 30.5, so that is 5. Okay, and the frequency is given to me as well, so that is 15. 15 is the frequency. Okay, and over here the frequency is for 26, 30 is 13. Okay, so we'll be using this to work out our, and what's for the given one, I've been given the width and the height of this as well. The width is 4 and the height is 6. Okay, let's start this, people. The width is the easiest one. class width of 10 is represented by 4. So class width of 4 would be represented, class width of 5, sorry, would be represented by half of that 4, so that's 2. So guys, the width is 2. That's your first answer. Okay, now the height. For height, what do we advise you to start from the frequency, because frequency is given in both the cases. So frequency times by something, k, is equal to the area. Okay, and area is, how much area is 24? So guys, frequency 15 times by something is equal to 24, and that something is 24 divided by 15, which obviously gives you what? If my calculation is correct, 8/5, right? Okay, so over here as well, we have to follow the same process. So frequency 13 times 8/5 should give me the area. Okay, and 13 times 8/5 gives me 20, 0.8. Yeah, so 20.8, right? So that means the area is 20.8, and then if the area is 20.8 of a rectangle, width is 2, so height would be 20.8 divided by 2. The height would be 14, 10.4. That's my mistake, guys. So height is 10.4. So once again, learn it, guys. The width of the bars will be straight in relation with the class width. That's 10. So divide that by 2.5. So 5 divided by 2.5. The answer is 2. Okay, or just straight away 10 represented by 4. So 5 is the 2. For height, you need to work the scale factor between frequency and the area, and use that scale factor into the second one to find the area. Then use the height equals area divided by the width. The next two questions in representing data is about the box plots. Okay, in the first one, they've given you some data, and they've given you the formulas for finding the outliers, and you need to see if any of them is outlier or not, and then complete the box plot. Okay, and in the second question, they have given you a box plot. They will ask you to read this box plot with this two crosses, and we're going to talk about this. Okay, so we'll do both these questions one by one now, and then we finish with the representing and interpreting data. Step one is to calculate the boundaries for outliers. The first one is Q3 14 plus 1.5 times the quarter range, which is 24.5. That any value bigger than 24.5 will be an outlier. So that means 25 is an outlier there. For the on the lower end, 7 takeaway. This is Q1 takeaway 1.5 times 14 minus 7. This is minus 3.5. So any value which is less than minus 3.5 is an outlier. That means the 3 and the 4, both the lower values are not an outlier. That means the box plot will start properly from 3 and should end up at 20. Then we mark 25 as a cross on that box plot. This is how the box plot should look like. Okay, so that's how we draw a box plot with outliers, shows outliers. I mean, sometimes you can join them, but I prefer this way, just write outliers just as the cross. And the next question is this: we have to find the times 75%. We should know that 75%, the Q3 upper quartile is the point below which 75% of the data lies, and Q1 is a point below which 21% of data lies. So guys, work these answers out. Let's see if you can match with mine. These are the answers, and the two crosses are the two outliers. Sometimes I've seen they've asked you reasons. What do you think reason could be? Obviously, running a race, somebody might have got injured, or somebody might be special needs, or they might be have special physical needs to complete the race. Okay, so that's fine. The next thing I've decided to do is large data set. I mean, obviously there's a lot to cover in this, but I'll just give you the basic important points. And why do I do this in these chapters? Because large data set questions comes mixed with this chapter 2 and chapter 3 and chapter 1, which is about sampling and stuff as well. So there are, first of all, locations. There are 1, 2, 3, 4, 5 British locations there. And there are 3 international locations, the Beijing, Perth, and Japanese. What you need to know is the position of these towns and where they exactly lie. in the map. Okay, so they sometimes this is important for you as well. I'm copying a work done by one of my students, so it's important to know things about large data set. Okay, and this is obviously a worksheet from the internet. And May to October, these are the years. Okay, so where this exactly things lie. These are Heathrow is inland. These are coastal. Okay, Camborne's coastal, and above equator, the towns below equator. Okay, and these are the important things. I'll come with some more over here now. So these are my summary points for this last data set, and you can see, and these are the 8 variables you measure. I've given you units as well. Important points, very important points, people at the bottom is if it's not applicable, then you do not include this data for calculations. And if it was trace, then you would include this data values for calculations, and the values would be 0 for trace. Once again, if it is not applicable, do not include these data values for calculations. Just ignore them, so frequency will be less. And if it's trace, you need to include these data values with the 0 as the value, so frequency will still stay the same, whatever they've given you. Okay, so that's my last data set thing, right?